Well, hey, and welcome to Blockchain, Cryptocurrency, and Web3 Foundations, Module 9. Today, we're going to be talking about the future of Web 3.0. As per usual, do take some notes of your thoughts as we're moving through these slides. We'll be discussing this in the discussion somewhat. So throughout this course, we've talked a lot about blockchain and potentially how it's maybe not the best thing to use. And I think that we might have found that in some of the class discussions as well as the portfolio piece that we're working on now, that not everything is catered to have a blockchain integration, right? But that said, it really does drive us all towards some more robust decentralized systems in general. And I think of that both from a technological perspective and societally. We're doing some really interesting things in this whole industry. So then, really, what's blockchain's impact? Even if it's not the right fit for everything, it can do a lot more than just that. So I think with respect to technology and cybersecurity, there's been an explosion in cryptographic research. And really, this is a large increase, mostly centered around what's going on in cryptocurrency that we've seen. It's what's enabled technology in general, but it's also fed back into this, the desire to have better cryptographic primitives and to make them more robust in this particular manner. And beyond just the more academic pursuits of cryptography, there's a lot of innovations around cybersecurity's principles of using key management better, specifically for end users. So, cybersecurity password management is a big deal, and it's a hard thing to do right. And moving more towards a key-based authentication with private and public key cryptography, wallets are doing a lot of the hard work to make the leap to better systems for doing user authentication. So that's pretty awesome, right? And I would also say that this new paradigm that we have, this trust machine, this blockchain thing, right, it's a new security method that now, instead of using firewalls and authentication schemes, we can entrust that the incentive mechanisms and the economics are really what drives this human nature and enforces the right thing to happen. And this really is changing a lot of this third-party intermediary trust that we need. And that's basically software eating the world in this particular case. This industry is doing a lot to get rid of third parties that otherwise would have to manage these kind of data. And then distributed systems, really in general and broadly, it motivates interoperable standards. As we're talking about blockchain, everyone's in the right mindset for how to design systems around these large scalable systems that you may not trust every actor on. So interoperable standards between these are developing, whether it's blockchains or other distributed systems, which puts us all in a better place to work together, right? It also does some pretty awesome things, especially around key management again, about diffusing and really diluting risk and attack vectors. So when we have centralized bodies that manage all of the data and permissioning of a particular system, then that is the central thing that anyone would like to attack. So if you're a black hat going in, if you have one place that you need to corrupt versus potentially with distributed systems and everyone owning their own data and their own access permissions and things like this, you have many different attack vectors that you need to go after. So it depends on the situation, but it really does change the cybersecurity principles you might see out there in the world. And it's not just blockchain. Blockchain is inspiring better use of this kind of system. And then immutable commit and reveal methods are really becoming possible with blockchain systems. So if I submit something on chain that you can't read, except I know what it was beforehand, I cannot change this after the fact and can be potentially publicly audited, which is a new interesting method that people are exploring how to use. And then moving out of technology more into what is the impacts on society and policy, we really do have a pretty novel way to have censorship resistance. And as long as you're willing to pay some transaction fee for public data to be submitted to one of these blockchains, it is immutable, right? And this can be widely distributed and do some bypass basically any other blockers that could be in the way of this, because this distributed system is going to find its way around whatever firewalls and be trying to stop it, right? So that's pretty amazing on the censorship front. And then also transparency. I would say radical transparency, as we've seen, is that all transaction it's optionally open. We can do things to get around it, but by default and by and large, all of this information is public, right? And we can also have oracles to lock in physical to digital information, right? So something out in the real world, an event that had taken place, or potentially something like voting, right, that had taken place. You can put a digital immutable record out there. And then governmental data, which I would think is personally a very good place to put a lot of this more transparent, publicly verifiable things that we'd like to know aren't being corrupted over time. And moving forward more into society at large, I think that we see a large movement of people, especially here in the US, where a very individualistic culture, demanding for decentralized like tooling, things that empower the individual. And especially when it comes to privacy, which we'll get into here in a moment, there is a lot of owning your own data is put out there in the world. And whether or not blockchain is the right solution for this, it's really getting the right people in the same room to discuss how to do it in the right way in a decentralized world. And one really interesting part that I think we've seen a little bit of in the course, but I encourage you to go and check out, is decentralized autonomous organizations and digital governance that's happening, basically an opt-in society where having some token, whatever kind of token, a fungible or non-fungible token, gives you some access or weight in a DAO, right? And so this is generally governed by smart contracts that enforce policies. This can be minimal, where it's literally just managing money with potentially a multi-signature account that you'll have many people agree on how those funds should be spent, to very complex systems that have a whole bunch more of on-chain voting that may or may not be weighted by the tokens that you have that are associated with your particular DAO. And there's a lot of skin in the game mechanisms effectively built in here, is that you can audit publicly on a permissionless place, right? That you have some tokens associated with this DAO and you might have voted in a particular way. And one thing that was discussed pretty well by the GeoWeb presentation that went on last week is these radical markets experiments. So I encourage you to check out the book if you're interested in things like a self-assessment tax and things like this, a Harbinger tax around semi-publicly owned property, and really interesting things that are enabled by smart contracting policies that otherwise would be very, very logistically difficult to implement in the real world, maybe impossible. And then I think lastly, I would say that blockchain is really a call to action. And what I've done with a decent chunk of my free time here is really bringing people together to discuss whatever it is about cryptocurrency and blockchains that gets them excited, why they're interested in this, why would they come out to meetups and events and conferences. And it's amazing to me, at least, that how cross-discipline and cross-creed are people drawn to this particular technology. So whatever it is, it has some magic stuff that's bringing a lot of people together that otherwise would never get along. People like, for instance, crypto anarchists that are absolutely against anything government related effectively, all the way out to bureaucrats that very much would like to see it used to vote on policies and manage other things. So these people can come together and have a productive discussion about this technology. It's really an interesting thing to see. And so moving back more into the technology side, there's some key innovations that I think moving forward into the future of Web3 that will expand beyond this class and potentially deprecate some of the things that we've been talking about, and specifically like what assumptions you should make about a blockchain, if it should or should not be used. Those flowcharts are probably going to be changing. So easy button solutions we've talked about. I think that blockchain as a service is becoming more robust, and some of the failure points in terms of trust that we talked about are starting to become resolved, and probably will be more as we move into the future. And the distinctions about what needs to be private to yourself to trust versus what can be managed out by a third party in the cloud will become more apparent and more standardized. And then interoperability, blending the right tools with what do you want to use a blockchain for exactly, and integrations into other wider applications is going to become much, much better. And you see more and more compared to a few years ago, it's amazingly better. I imagine in a few years from now, it'll be a whole nother magnitude. the off-chain data integrations. When we're talking about Oracle systems, I think that the data is really trying to understand if it's true or not on-chain. These systems are still in their infancy, but as they become more robust, we'll see them used much more often for things other than just pricing an asset correctly, which is what they're primarily used for now. So thinking about ecosystems of IoT, for instance, all kinds of temperature sensors, coordinating and verifying information about what they're all reading is something that we could potentially put on one of these on-chain systems. And much more. There's a primer here in the slides link if you'd like to check that out. And then one that's close to me that I'm very interested to see is privacy solutions. So back to the more applied cryptography side of things, there's some really interesting things going on with homomorphic encryption. And effectively, this is being able to process a function on a remote machine without that machine knowing what the input is or what function it's running or what the output that it produced was, but you can. So at a fundamental level, so I would check out this homomorphic encryption link if you'd like a little bit more understanding there. And that's also wrapped up very tightly with this zero-knowledge proof cryptography, or ZK proofs as they're called for short. And this can really do some amazing things with many different aspects of Web3 moving forward, primarily centered around two things. That's the privacy that is going on around transactions. So you can very robustly send someone some funds with no one but the two parties who are involved have any idea of the amounts that were sent. And you can wrap it up further and have no idea that the accounts that were involved in your transaction were even there on a blockchain. So if you're interested, check out the zero-knowledge proofs for privacy. It's really interesting. And the other one is layer 2 solutions. So ZK rollups, zero-knowledge rollups, can enable this, and I'll get into that a little bit later here. But these enable privacy not necessarily through cryptography, but simply through being a side channel to the blockchain, so that information doesn't necessarily land on the blockchain itself, but can be anchored on this blockchain. So there are many payment channel solutions, effectively where you establish a connection to another account and you bind in a cryptographic agreement your accounts to this other account with a particular amount of funds that then off-chain, you can negotiate payments back and forth between this and potentially build a network out of these agreements off-chain. The Lightning Network is an example of this that's primarily targeting Bitcoin, but is generic, can be used other places as well. As well as we've talked a little bit about consortium chains, hybrid and private and public chains here, where the private side can do a lot of transactional information a la carte. You trust this side chain, as we call it, to come back and report to the main chain in a public way that can be audited, but all the things that had happened off of it wouldn't necessarily be. So really interesting stuff in the privacy and applied cryptography sides that are going on. So we are touching a little bit on that second layer stuff, and scaling solutions I think are still one of the most sought after things in blockchain. And as we talked about this DCS triangle, where it's very difficult to get planetary scale and super highly scalable and consistent systems, right? So we're really trying to push the boundaries on the scaling is the key issue for a lot of people now. And that's because we all would like to see these be used widely, globally, for a lot more than they are now today. So second or third layer solutions and beyond, they settle down on blockchains. So most of the transactional logic actually lives somewhere else and never gets reported to this distributed database. And there's different ways you can go about it, some more reliable than others, but these are being explored now. So side chains are one example of these, where it really is, as we mentioned, like a consortium chain or things like this, where it is another blockchain of sorts, or potentially totally divorced from a blockchain. This can be its own system that decides upon the final results that will be reported back to a blockchain at some point. Ethereum Plasma is an example of this, although this, for the most part, I think has been abandoned at this point for a sidechain implementation on Ethereum in particular. Payment channels, as I mentioned, Lightning Network is definitely one to check out in that front. And then it's really not just blockchains. We talk a lot about linear flow, right? It's one block that leads to the next, to the next, to the next. And there's also a class of algorithms called directed acyclic graphs, DAGs. And these have fallen out of the popular favor. I would say that somewhere in the 2016 to 2018 range, there's a lot of hype around these particular solutions. They're still valid. They're still being worked on. Swirlwinds, IOTA, and Ocean Protocol are examples of these, where it really isn't just a linear blockchain. It is a coordination of many different asynchronous events that are happening to make blocks effectively that all only can progress in one direction. So you don't get any loops or feedback. You can think of it as a blockchain, but there's many components to that particular block that are happening apart from each other that eventually come to consensus later on down the road. So it's a more complex schema, but it's definitely one worth investigating if you're more into the computer science side of things. And I think we're just scratching the surface. I would say that this chart here doesn't even really cover most of the things that are being worked on now if you really want to get into the scaling solutions. But it really does illustrate some important pieces here. One thing that I haven't mentioned yet is hard forking. So effectively, literally just making a new network based on the old network, maybe some minor tweaks to differentiate it. It scales the blockchain and by making another one, right? It's effectively parallel processing, but they're independent of each other now. And various consensus mechanisms are being tried. So proof of work is the most popular that we see in Bitcoin. Proof of stake is potentially coming up for a lot more chains that people are interested in looking at, and variations on what that proof of stake looks like. And then, as we mentioned, beyond just blockchains, other distributed layer types and various other scaling second layer things that come back to the root of trust on a singular blockchain. So way back at the beginning of the course, we asked, what can blockchains do? And they can sure do a lot of things. But I think that really, as we see now, it's not so much blockchains, but what can Web3 do? All these dApps that we've talked about can be empowered by blockchain, but maybe they shouldn't even be on a blockchain. There's a lot more to this whole decentralized movement than just money and just cryptocurrency. So, and to enable all of these things and more, then we need to look beyond just the blockchain and to these other tools that are emerging. So with that, that's it for Module 9. And we explored some of the technologies that are just starting to come into production and things that are on the horizon that I think we should all really be excited about. That can fundamentally change some of the things we learned in this course. So in a few years from now, it might be that a lot of what we learned about could be superseded by some really cool stuff that's going on. So in the next module, it's time to close the course. And we'll have the class final presentations. So you won't be seeing me on screen, you'll be seeing your peers on screen. And I really do encourage you to, as soon as possible, start to do some dry runs, whether recorded or not, with your peers. Reach out on Canvas or email or Keybase, wherever it's convenient. And try and get this done before the main final event, recorded and published, out for everyone to review. All right, with that, thank you all. See you later.